Hello everyone. Today we'll take a look at the field of quantum computing. So what is quantum computing? What are quantum computers? Why it is so popular and why so many people are investing in it? So let's take a look at this. So the term quantum refers to a smallest possible unit of energy or a matter which we can operate upon. So in this case, in case of quantum computers, it is atoms. So in quantum computers, we utilize these atoms to do our calculation. Now these atoms has quantum properties. So we are utilizing these quantum properties and we are performing some operations on these individual atoms. Now we refer these individual atoms as qubits. So we are performing operation on these qubits, and it is found that a quantum computer is much more efficient than a classical computer. Now the theory of or the idea of quantum computer originates with the paper of Richard Feynman. So he gave a talk named as "There is a plenty of room at the bottom," where he talks about creating circuits with fewer atoms, like 7 atoms, creating circuits with 7 atoms, or creating a circuit with 1000 atoms. So from there he gave the idea and this field started, and slowly over the period of time, with the advancement of technology, people have realized a fully working quantum computer. Now this is how a quantum computer looks like. So this is the silicon wafer where these quantum particles are present and where we are manipulating the atoms, and this whole circuit, and there's a whole circuit around it. So to realize these quantum properties, we need this wafer to be at absolute zero temperature, that is minus 273 degrees Celsius. So to do that, this whole system is built to keep this wafer cool at absolute zero, and then we manipulate those atoms to do our task. Next is we see how do we what is the difference between classical and a quantum computer to understand better. So if we see, this quantum computer is totally a different computer than a classical one. Now classical computers started or came into the picture when transistors were invented. So this is a typical transistor diagram looks like. So transistor is nothing but a switch. It's a switch. If we switch it on, current will flow from this part to this part, and if we close it or if we do not switch it on, current will not flow. So in case of classical computers, we are controlling the flow of current, but in case of quantum computers, we are controlling individual atoms and we are creating individual atom interactions. Now if we talk about the principle based on which these quantum computers are based on, so classical computers are based on digital electronics, and quantum computers are based on quantum physics. So quantum physics is a field where we study these quantum particles and their behaviors. So using these principles, we are able to build quantum computers, and quantum physics has really helped us understanding many of the concepts in physics itself. Now the minimum amount of information which we can represent in a classical computer is a bit, and in case of quantum computers, which we call a qubit. So in case of a bit can either store a 1 or a 0. 1 means if we apply 1 on this transistor, that means current will flow. If we apply a 0, that means current will not flow. So in case of a bit, it can either contain a 0 or a 1. But if we talk about qubit can have its value as 0 or 1 or both together in a superposition or in a probabilistic in a probability, in any probability. it can have 70% of 1 and 30% of 0, or 60% of 0 and 40% of 1. And in any superposition, or in any probability, it can contain both the values. Similarly, if we have 2 bits, let's say we have a system, or we are utilizing 2 bits, so what are the possible value of these 2 bits? So in case of classical bits, the possible values we have is 0001 1011 for 2 bits to hold. In case of qubits, if we have just two qubits, they can contain these 4 values at an instant. That means at an instant it will have all 4 values present. Just like for a single bit, it can contain 0, 1, or any probability or any superposition of these two at an instant. But if we talk about a classical bit, that will either contain logic 0 or it will contain logic 1. So what are the interesting properties we have seen so far? So interesting properties of qubits are superposition. So superposition means it can contain all the possible values a qubit can have at an instant. It can have all these possible values present in any superposition. It can have a 70% of 0, 30% of 1. At an instant, it can contain all the values. Second thing is entanglement. Entanglement is a property where if we take 2 qubits and we entangle them, that means both are non-separable. Non-separable means if we are performing some operation on a qubit, then other qubit will also get affected with it. So let's say if we manipulate a qubit, manipulate its value of the qubit, then then other qubit or other entangled qubit will also get affected with it. So with this we achieve a property called teleportation. In teleportation, using these entangled qubits, we transfer the information from one qubit to the other qubit. So that's a really interesting property which we'll talk about sometime later. Now if we talk about the applications or the achievements, let's talk about achievements, what we have achieved so far using quantum computers. So quantum computers are able to break the current RSA encryption. So our whole internet security, our secure logins and everything works on RSA encryption, and using quantum computers we are able to break this encryption easily, which a supercomputer will take years to break. Quantum computers are breaking it in just a few hours. And the principle here is any RSA, any encryption works on big prime numbers, and we have to factorize them to break it, and we are able to do the prime factorization very fast or extremely fast in quantum computers. Second, what we have achieved is faster searches on databases. So let's say if database which has a size of n entries in it, then using quantum computers we'll get our result in square root of n time. So let's talk about its applications. So this applications of the quantum computers are as simulations. We are using it for simulations like medical drug development simulations and understanding the nature of quantum particles itself. So in 1982, Dr. Richard Feynman wrote a paper simulating physics with computers. So where he talks about that if we want to understand these quantum behavior of these particles, then we have to build a quantum computer itself. So we are utilizing quantum computers for simulating, understanding the nature more better, and medical drug development. Second thing is, since quantum computers have broken our current internet security, so people are building quantum network or quantum internet, which we can say. where if some hacker is trying to read the information. Let's say we have some data is being sent over the quantum network, and if some hacker comes and tries to read the information itself will change. So that way the receiver will know that data has been read by somebody over the internet. So that's secure it is. And the third is general computing. So in general computing, like databases and other applications, and people are using, or people are doing machine learning over quantum computers. So they are training their algorithms and all. So like this research is going on, and this is a very interesting field. Even since quantum computers are in development phase, they are still developing the technology enough to build a very good quantum computer which we can use for journal purpose, like we are using our classical computers. So for that, till it develops, IBM is teaching this quantum technology to the school kids, so that till our technology is ready, we have sufficient number of engineers ready for working on these fields. So it's a very interesting field, and I believe everyone should know about it. So that's all for today. Thank you very much.